Hari Om girls, as we are discussing the third module of software engineering, we are currently talking about function oriented design, in which we have discussed what is a function oriented design. We have also talked about how important the function oriented design is. We have also discussed what is a functional system, in which we have seen what is a top-down structure and what is a bottom-up structure, which is otherwise called as reusable structure. We have seen an example. Then we have also seen some of the design notations which will be used in the function-oriented design. Out of these, we have seen data flow diagrams and data dictionaries, and we were discussing the structure chart. We have seen what is a black box in a structure chart, and this is the diagrammatic representation for a structure chart which we have discussed already in the previous video. And what are the different notations used in the structure chart? When we have seen the explanation for all the notations used in the structure chart, and this is one of the examples we have discussed for the structure chart. Another example is this one which we discussed. We have also seen the two forms of structure chart. One is called as transform centered structure chart and the other one is called as transaction centered structure chart. Okay, so all these topics we have already covered in our previous video. In this video, we are going to talk about the pseudocode and the functional procedure layers that are used in the pseudocode. We have seen the 4 different notations used in the function oriented design are data flow diagrams, data dictionaries, structure charts and pseudocode. We have already covered what is a data flow diagram, what is data dictionary, how data dictionary is used to give details on the data flow diagrams, and we have also seen how a structure chart must be designed. Now the next notation used for function oriented design is what you call as pseudocode. So pseudo itself is called as, which is not real. So this pseudocode notation will be generally used in both preliminary design phase as well as in the detailed design phase. Right from the preliminary to the detailed design phase, we can use the pseudocode. Now when you take the pseudocode, like flowcharts, pseudocode can be used at any desired level of abstraction. So when you are getting into the details of each and every design, you can go for the pseudocode at any desired level of abstraction. So wherever you want to give some kind of programming notations, then you can go for the pseudocode. Using the pseudocode, the designer describes what are the things it can the pseudocode can describe. One, the system characteristics can be described, and all these system characteristics will be described using short and concise notation, which will be generally in English language phrases, which will be structured by keywords such as if, then, else, while, do, etc. So the best example that I can give here for the pseudocode is what you write for your algorithms. You have lots of algorithmic notations used. All these algorithmic notations can be called as a pseudocode. Or even you have PDLs. PDLs, please make a note of it. It is program design language, not programming language. It is program design language. So the design language will also be using notations like if, then, else, while, do, etc. Right? So these English phrases can be expanded into more detailed pseudocode until the design specification reaches the level of details of implementation language. So wherever you want the details, so that the details can be used for the coding process. So wherever you use the details, if the detail is not up to the specification, go for next level of detailing. Like that, you can keep on adding the next level of detailing until it reaches the implementation language understanding. And not only that, the pseudocodes can replace flowcharts and it reduces the amount of external documentation required to describe the system. So wherever you want to replace the flowchart, you can use the pseudocode, because flowcharts cannot give you an idea of like how a programming code can be done. But whereas if you represent it as a pseudocode, easily the coding people can easily understand how it can be implemented. Now when you take the pseudocode will be generally having functional procedure layers. Different functional procedure layers can also be used for representing the function oriented design. So in the function oriented design, first we have seen the design notations. In the design notation, we have seen data flow diagram, data dictionary, structure charts and pseudocode. Now apart from the design notation, function oriented design also follows functional procedure layers. We are not going to discuss functional procedure layers under pseudocode. Actually the functional procedure layers is coming under function oriented design itself. So in the function oriented design, first part we have discussed what are the design notations used, and the functional procedure layers becomes the second part of function oriented design. Now when you take the functional procedure layers, the functions will be built-in layers and additional notation is also used to specify the detailing. And when you take these functions which are built-in layers, you can have different layers, like different levels will be used to represent the details of the functions used. Right? Instead of calling it as layers, you can also call it as levels. So different levels will be used to represent the details of the functions. And these levels describe, in level 0, you can have the function name or you call it as procedure name. Then you can have the relationship to other system components, something like part of which system, called by which routine. These kind of information can be specified. So if you have at level 0, suppose say for example you call a function as admission process, then if you call it as admission process, what is the relationship of admission process to other system components? Say for example you have another system component like fee management. So what is the relationship between admission process and fee management? That can be specified here. Then you can also describe the function purpose, like why you have included admission process. That kind of description can be specified. Then apart from that, who is the author of that particular design and who, on which particular date this function is designed, that can also be specified. So in general at level 0 we will have the procedure name and the connection between the procedure and other system components and the brief description of that particular procedure, then who has designed that particular procedure on which date. This will be available in level 0. Then in level 1, we will have the function parameters, like what is the function you have specified in the previous level, that is level 0. Now for the function what are the parameters, what are the problem variables, what are the different types, and what is the purpose of each and every variable that can be specified here. Then if the function is using any global variable, any sharing information, any problem variable is being used, that should also be mentioned here. Then routines called by this particular function. So which are the routines or subroutines or other procedures called by this particular function, that should also be mentioned here. Then what is the side effect? If this function is executed, what will be the state changes in the system? That must be specified. And what is the input and what is the output? So in the previous level, what you have done, you have just given the function name. Then in the next level, what is the next level? Level 1. In level 1, what we are going to do? What are the parameters being passed? Whether the function is using any global variables, and what are the other functions called by this particular function. Side effects means what will happen to the system when the function is being executed. What is the state changes in the system when this particular function is executed? That is what you call as side effects. Then of course, what will be the input to the function, what will be the output to the function. So these are the things you will be mentioning in level 1. Then in level 2, interestingly, we go for all the local data structures. So all the variables, every data structures, everything used inside that particular function will be mentioned here. All your temporary variables, local variables, everything will be specified. And if you have any timing constraints for that particular function, like this function can be executed only on this particular time or only on this particular period. Say if it is admission process, the function can be executed only during June, July. So only when the admission is taking place, this function will be executed. Like that, if you have any timing constraints, that can be specified. And if you have not almost, of course, you will be having the exception handling will be specified in all the functions. So those details can be specified here. Then if you have any other constraints or any other limitations for that particular function, that can also be specified. So this is inside the function. What is happening inside the function? Whether there is a constraint, whether there is any limitation, whether there is any exception handling, all those things can be specified here. Then at level 3, we are going to have the body of the function. So in the body of the function, you will have the structured chart, or you can have the pseudocode, or you can have both structured chart and pseudocode, or you can have decision tables, you can have flow charts, etc. So all these things will be dealing with the process, the exact process that is happening inside that particular function, which you call as the body of the function. So in general, the functional procedure layers can have 4 different layers starting from 0 to 3. So level 0 will have the function or procedure name. It will also the function and the procedure name, relationship to other system components, and the brief description of the function, purpose. Then you will also have the date and author of that particular function. Then in level 1, all the parameters being passed, the global variables that are used, then what are the different subroutines called by the function, and what happens when this function is being executed, you call it a side effect, the input output of the function. Then in the next level, we will be having the description of all the local variables or the temporary variables or the data structures that are used in the function. If you have if you have any timing constraints or limitations, that can also be mentioned here. Then in all the sort of exception handlings should be mentioned in level 2. Then the last level, level 3, the complete procedure, the process will be mentioned as the body of the function, which can be represented as a structure chart, pseudocode, decision tables or flow charts. These are the functional procedure layers we can have in our function oriented design. So when you take functional and object oriented design, for large and complex applications, object oriented design is more reliable and maintainable, whereas for small applications, function oriented design is appropriate. And not only that, all the standards, methods and case tools for functional design are well established. There are lots of case tools available. Then you have lots of methods and standards described for the functional design, or you call it as function oriented design. So that's it about what is function oriented design. So under function oriented design, we have discussed what is function oriented design, what are the two structures used, top down and reusable structure. Then we have discussed what are the different design notations used. The 4 design notations are data flow diagrams, data dictionary, structure chart and pseudocode. Then the last topic we discussed is functional procedure layers, in which we have seen how the function details are given in 4 different layers, right? Then finally we have seen object oriented design is used for large and complex application, whereas function oriented design is appropriate for small scale applications. Okay, so we will be discussing the functional design process. In the functional design process, we will have data flow diagram or data flow design. It will be modeling the data processing of the system using data flow diagrams. Then you have structural decomposition, in which it models how functions are decomposed to sub-functions using graphical structure charts. Then the detailed design, all the entities in the design and their interfaces will be described here in detail, and these may be recorded in the data dictionary. And not only that, and the design will be generally expressed using the program design language, which you call as the pseudocode. Okay, so that's it for the functional design process. We will be discussing the structural decomposition, how it can be achieved, what are the guidelines in the next video.